Hello everyone. Today I am going to tell you how you can find the eigenvectors of a 2 into 2 matrix. In my previous lecture, I have told you how you can find the eigenvalues of 2 into 2 matrix. I have just broke this lecture into two parts so that you can easily understand both the parts. This first part, I will give the link in the description and in the information button above also, so that you can refer to that lecture as well before finding the eigenvectors. Because the important thing is, before finding the eigenvectors, you must have the eigenvalues. So for this matrix, I have already got the eigenvalues. I will not solve for eigenvalues in this lecture, as you can refer to my lecture in the to my previous lecture for saving the time. So for this given matrix, the eigenvalues that I have solved for came out to be lambda is equals to 8 and lambda is equals to -2. So we will use these two values to find their corresponding eigenvectors. So I have told you in my previous lecture that eigenvectors are basically the vectors that does not change their direction even after linear transformation, that is scaling or rotation. There are different types of linear transformations. So this lambda is representing the eigenvalue, and I will find the eigenvectors corresponding to these two different lambda values. So we'll start with, first of all, corresponding to lambda is equals to 8, we will find its corresponding eigenvector as, what I have to do is, I have to solve for each eigenvalue. What I have to solve, I will write the formula here. So the formula is that you have also seen in its part in the characteristic equation in my previous lecture. A minus lambda I multiplied by x equals to 0. So this is 0 vector. X is a vector, that is the eigenvector. So I can write here that let this x be the given eigenvector that we want to find. So the value of this eigenvector that we will find will be what we are actually wanting in this lecture. So be the given eigenvector. So now we will solve this equation to get the value of this x dash. So what I have to do is I just need to put the values of A, and lambda is already given, I is the identity matrix, and x will be the unknown, as we usually use in word problems, that whatever we want to find, we just start assuming it. So we have just assumed that x dash is the eigenvector corresponding to lambda is equals to 8. So now I'll start putting the values in A minus lambda I into x dash to solve it further. So it will be, after solving it, I'll just write it after solving it, because we don't have enough space and time here to solve it for the entire A minus lambda I. A is the given vector, lambda is the value of 8, and I is the 2 into 2 identity matrix, that is 1 0 0 1. So you can solve it by yourself. If you have any problem, you can refer to my previous lecture, in which I have already solved all these elements that are inside the bracket. So A minus lambda I will be by putting lambda is equals to 8 minus 1 3 3 and minus 9. So this vector is representing this all the values inside the brackets. Now what is x dash? Now x dash can be x1 or x2. It can be x and y. It all depends what notations that you want to use. So I will use here x1 and x2. This is basically eigenvector that we want to find. Equals to 0 vector is 0 and 0. Now by using this system, this is the homogeneous system of linear equation, I will write the equations. How you can form the equations? You can form the equation as by going from here and like this. Now I can write the equation as minus 1 into x1. It will be minus x1 plus 3 into x2. 3 multiplied by x2. And then this one equals to 0. This is one equation, and the other will be like, now we will take these one and then multiply them with in this way, like 3x1 minus 9x2 equals to 0. Now keep this in mind that after solving both these equations, you will get the same equation. If I solve this one, I will get the same equation as x1 is equals to 3x2. And similarly, if I solve this one, I'll get the same equation. So I'll write it once as x1 is equals to 3 times x2. So this is the equation. So to solve it, or for our convenience, we can say that let x2 is equals to 1. So if I put the value of x2 is equals to 1 in this equation, what will be x1? X1 will be equals to 3. Now I have got the values of x1 and x2, and I just need to put them back in the above. Like if I put them here, it must satisfy the equation, or you can say I have got the eigenvectors corresponding to lambda is equals to 8. So I can say that the eigenvectors will be, these are x1 and x2. So it will be x1 is 3 and x2 is 1. So this is the corresponding eigenvector to the eigenvalue of lambda is equals to 8. So after this, keep this in mind. If you want to check whether this value is right or not, you can put this value in this system of equation, and you have to check whether both the sides are equal or not, and you can easily find that the values of x1 and x2 are right or not. Or you can say you can check, or you can say you can find the proof of that whether the values are right or not. Now we will also solve for lambda is equals to minus 2. So for lambda is equals to minus 2, we will have, I have to write the entire process, that is a minus lambda I into x dash equals to 0. So here what we have, x dash is x1, x2. Again, I'll write here that let x dash be the corresponding eigenvector to lambda is equals to minus 2. So what I have to do, I have to write again the same a minus lambda I. After solving, I'll get minus 1. What I will get here, keep this in mind, a minus lambda I will be different for both the eigenvalues, because the eigenvalues are different. So while solving it, the value of this matrix will be different. So for lambda is equals to minus 2, it will be, 9, 3, 3, 1. And the vector that and the corresponding eigenvector will be x1, x2 is equals to the 0 vector, that is 0, 0. Now what again we have to convert it into the system of simultaneous linear equations. It will be, again we will do like this, 9 have to be multiplied with x1, then plus sign, then 3 should be multiplied by x2 equals to 0. Then here again we have to go up, 3 should be multiplied by x1, 3x1 plus x2 equals to 0. Again both these equations will give you the same result, that is, so it will be solved as 3x1 is equals to minus x2. So let, again we have to put x1 is equals to 1, and what we will get is x2 is equals to minus 3. So in this case, again the eigenvectors will be x1, x2, as we have assumed above, will be equals to x1 is 1 and x2 is minus 3. So keep this in mind that eigenvectors can never be 0. So keep this in mind, and here we have got the eigenvectors corresponding to lambda is equals to 8 and lambda is equals to minus 2. So this is that's all from today's lecture, that how you can find eigenvectors of 2 into 2 matrix. In my next lectures, I will tell you how you can find the eigenvalue and eigenvectors of 3 into 3 matrix. Thank you.